Today we're going to work on solving word problems involving rational equations. So we have simplified, we've multiplied and divided, we've solved rational equations, and now we're going to apply this all to solving some real life or word problems. The two word problems we're going to deal with are mixture and work problems. So here's an example of a mixture problem. Maya adds a 70% acid solution to 12 milliliters of a solution that is 15% acid. How much of the 70% solution should be added to create a solution that is 60% acid? So if we would draw a picture of this, so we have a beaker or a container that has a 15% solution, and we've got 12 milliliters of that. We are going to add to that a beaker of 70% solution, and we're going to add, we don't know how much of that. So when this is combined, our solution is 60% acid. How much of that do we have left? We have the 12 original plus the X that we added. All right, so now, converting this to an equation, if we look at this right here, we have a 15% 12 milliliter solution. So talking about how much acid we really have, we have 15% of 12. Plus, and here we have 70% of, we don't know, or X. Here we have 60%, again changing that percent to a decimal, of a 12 plus X solution. So if you look at how this equation is set up, we have all our percentages of each, and we have the quantities of each. So this 12 right here and X together gives you the 12 plus X when added together. So now we just do the math. 0.15 times 12 is 1.8. Plus 0.7x, we distribute this 0.6, which should be 7.2, plus 0.6x, and now we solve. So we're going to subtract 0.6x, which is 0.1x, we'd subtract 1.8, which is 5.4, dividing by 0.1. Gives you X to be 54 milliliters. So that would be the amount that is added. So that's this X right here, the amount that's added. So when we're done right here, we're having 12 plus 54. This would actually be 66 then milliliters of a 60% solution. So here's another example of a mixture problem. So it says Jimmy adds a 65% fruit juice solution to 15 milliliters of a drink that is 10% fruit juice. So again, we've got a 10% solution. We've got 15 milliliters of that. We're adding a 65% solution, and we don't know how much of that to add. We're going to add as much of that as we need to create a 35% solution. And when we do that, we'd have 15 plus the X. So then setting up the equation, I'm going to have 0.10 times 15 plus 0.65 times the X plus 0.35 times the 15 plus X. So I'd have 1.5 plus 0.65x, distributing this 0.35, 0.35 times 15 is 5.25, plus 0.35x, and then solving the equation, so subtracting 0.35x from both sides gives me 0.3x. Subtract 1.5 from both sides. And I get Bear with me here a second. Gives me 3.75. And then dividing that by 0.3 gives you 12 and a half. So that's our x. That is what the amount of 65% solution that would be added to the original 10% solution. Work problems. So it says every year the junior and senior classes at SHS build a house for the community. If it takes the senior class 24 days to complete the house and 18 days if they work with the junior class, how long would it take the junior class to complete a house if they worked alone? So there's a couple ways you can set this up. Most textbooks will talk about this type of solution. So it says if it takes a senior class 24 days to complete a house, that would mean that they could do 1/24 of the job in one particular day. If they worked one day, they'd get 1/24 of it done. We want to know how long it would take the junior class to complete a house if they worked together. So we don't know that. We're going to let that be x. So the juniors could do 1 out of x each day, 1/x of a house. So we're putting these together, and if they work together, you can see it takes them 18 days to do it, which would be 1/18 of a house would be done in one day. So now this is a rational equation. So how do we solve this? This is what we learned in our last lesson. We're going to multiply by the LCD. The least common denominator of 24 and 18, I believe, is 72. So if I take 72 times this, I get 72 divided by 24, which cancels to be 3. Here I would have 72 over x. And this would cancel and give me 4. So I would subtract the 3. Get 72 over x is equal to 1. Multiply both sides by x. I get 1x to be 72. So it would take them 72 hours to do that. Now, this is the way that I use that I believe is a little bit more user-friendly, and this would be together over alone plus together over alone equals, this would be the number of jobs they're doing. In this case, we're painting one house, we're doing one complete job. So the seniors, as far as their together time, the together time in this case is 18. So I'd have 18 over something plus 18 over something, and I'm painting one house. The seniors' alone time is 24. The juniors' alone time, we don't know, which would be x. So then our least common denominator is 24x. And multiplying this through, the 24s would cancel here. I'd have 18x. Here my x's would cancel. I end up with 24 times 18, which is 432. And the 24x times 1 is 24x. Subtract my 8x from both sides. Divide, and I get x to be 72 again. So that's the number of hours, or number of days it would take the juniors to complete this alone or by themselves. Here's another example. It took Anthony and Travis 6 hours to rake the leaves together. So this is their together time. The previous year it took Travis 10 hours. That's Travis's alone time. How long will it take Anthony? We don't know that. So together over alone for Travis would be 6 over 10. For Anthony, the together over alone would be 6 over, we don't know, which is x. And what are we doing? We're doing one full complete job. So now I multiply through by my least common denominator. Make sure you show this work as you're doing the problems. Those 10s will cancel. You get 6x. My x's would cancel. I'd get 60. 10x times 1 is 10x. Subtract 6x. And I get x to be 15. 60 divided by 4. So it takes Travis 10 hours alone. It takes Anthony 15 hours alone. Together, they could do it in 6. So today's assignment, and your code word for watching this video, by the name or by your name on your assignment, please put algebra fun on that for word problems. But you'll be doing a problem with simplifying, with multiplying, dividing, and solving an equation, and then you'll have an example of one mixture problem and one work problem to do. Have a great day. If you got questions, please communicate with me or join a Google Meet.